Hello there, everyone. This is going to be the 3.2, I'm sorry, this should be 3.2 test review. There's going to be 7 multiple choice questions and 7 free response questions. And you'll have to be able to do these 6 things at a minimum. Okay, and the questions that we've come up with, they pretty much cover what you'll need to know. So example 1, it says draw 2 parallel lines A and B cut by transversal C. So here we go. There's A and there's B. And here's transversal C. Now it says mark angle 1 and angle 2 as corresponding angles. Okay, just choose any 2 corresponding angles here. So here's angle 1, and then this is going to be angle 2 right there because they have to be corresponding. Now it says mark angle 2 as an alternate interior angle to angle 3. So here's angle 2. Now it has to be alternate interior. So we got to go on the other side. We got to go up here. So that's angle 3. And then mark angle 3 as corresponding to angle 4. So here's 3, and then we jump down here. There's angle 4. And now they're asking what type of angles are angle 1 and angle 4. Well, we've got angle 1 and angle 4. They're both on the outside, so they're exterior. And we have one on the right side of the transversal, one on the left-hand side, so they're alternate. So they are alternate exterior angles. So if you have a problem similar to this, the point of it is that you know your angle relationships and their names and where they're supposed to go. Okay, example 2. Find the slope of a line going through the points A, -5, 8, and B, 13, -6. Okay, all you gotta do is use that slope formula. So we have y2, so -6, minus y1, 8, over x2, 13, minus x1, so -5. So you have -6 minus 8, that's -14. And then we have a 13 plus 5, so that would be 18. So we have -14 over 18. So it's going to become, we can divide both of them by 2. So it's going to become -7 over 9. Okay, example 3 there. Find the slopes going through A is 4, -8, B 4, 9. Okay, so y2 is 9 minus y1, so minus -8. Okay, over 4 minus 4. Okay, 9 minus -8 is actually 17, but then we have this 0 on the bottom. When you have a 0 on the bottom, you have an undefined slope. So its slope is undefined. Okay, and then the last one here, going through the points 4, -8, 7, -8. So we have -8 minus -8 over 7 minus 4. So 7 minus 4 is 3. -8 minus the -8 is actually -8 plus 8, so it's 0. So when you have a 0 on top, this means that you have a 0 slope. And your line would be horizontal. And in an undefined slope, your line would be vertical. Okay, in the figure to the right, it says if the measure of angle 5 is 3x minus 5, so here we go. It's 3x minus 5. And the measure of angle 3 is 7x plus 15. So 7x plus 15. Find the measure of angle 2. Okay, so if we see here, we can actually use our colors to help us. We have 2 pairs of parallel lines. So we actually only need 2 colors for this entire problem. And we can see that 5 and 2 are alternate interior angles. They're interior to the parallel lines going up and down. And this top line is acting as the transversal. So 2 is congruent to 5. And then angle 1 is congruent to angle 6, so we'll get them a different color. Angle 1 is congruent to angle 6. Okay, and then if you just slide down here, angle 6 is congruent to angle 8. And angle 8 is congruent to angle 3. An alternate interior there. I'll go back to our purple. So that means that angle 2 is congruent to angle 4, and so is angle 7. So we've got all of our angles marked here. So now we look at the ones that we have. We have angle 5, which is marked in purple, and we have angle 3, which is marked in red. So they're going to be supplementary. So this 3x minus 5 plus the 7x plus 15, that has to equal to 180. So 3x and 7x, that's 10x. And then 15 minus 5, that's plus 10. It's 180. Okay, so take away 10 from both sides. So you get 10x is equal to 170. Divide this by 10, and you get x is 17. But we're not done there, are we? We need to actually find the measure of angle 2. So the measure of angle 2 is congruent to the measure of angle 5, or it's equal to the measure of angle 5. So we need to take this 3x minus 5 and plug in our x. So 3 times 17 minus 5. And if you do that, 3 times 17 minus 5, it's going to give you 46. And that's the measure of angle 2. All right, next one. Example 6. Given the line 7x minus 3y equals 15, what is the slope of a line that is parallel to it? Okay, so all you got to do is solve this for y, and then look at that slope. So minus 7x minus 7x. So you have negative 3y equals negative 7x plus 15. Okay, and then now we divide by negative 3. So we have these cancel out, so we just get y equals, and then a negative 7 divided by a negative 3 is just going to be a positive 7/3. Okay, and then okay, so we have 7/3 x, and then we have this positive 15 being divided by this negative 3, so it's going to become minus 5. And so there we go. Oh, well, what's the slope of the line parallel to it? Well, if our original line is 7/3, well, the new line is going to also have a slope of 7/3. So there we go. All right. Number 7. It says, give the equation of a line that is perpendicular to y equals 2/3 x plus 3 and goes through the point 12, negative 8. Okay. So perpendicular. First off, we take the original 2/3 and we have to do the negative reciprocal. So it's going to become negative 3/2. So that's our slope. So now we use point slope form. So y minus y1, which is negative 8, equals to m, so negative 3/2, times x minus, and then x1, which is 12. So I have y plus 8 equals negative 3/2x plus 18. And then all you have to do is take away 8 from both sides, and you get y equals negative 3/2x plus 10. Okay, next one. It says, what angle relationships are the following angle pairs? Which are congruent, which are supplementary? So 1 and 8, they are congruent, and they are alternate exterior. Okay, 2 and 3. Look here, well, I don't remember. Are they congruent or are they supplementary? Well, what can I do? I can go through and I can color my angles. Start with 1 and 6 here, and then 3 and 8, those match. So I have a marked one and an unmarked one. If I have one of each, then they're supplementary. So look at 2 and 3, a marked and an unmarked. That means that they are supplementary. And those are same side interior. Okay, next one, 6 and 3. Those are congruent because they're the same color, and they are alternate interior. Okay, and then the last one, 5 and 7. Well, they are matching in their location, so they are corresponding angles, which makes them congruent. Okay, next few here. It says find the equation of a line that is parallel to the line y equals 2/3 x plus 3 and goes through the point 15 minus 8, or 15 negative 8. So parallel, we're going to keep our same slope. So we have y minus negative 8 equals to 2/3 times x minus, and x1 is 15. So y plus 8 equals to 2/3 x minus 10. Okay, and then now all we have to do is take away 8 from both sides. So y equals 2/3 x minus 18. Okay, example 10. It says from the diagram, line L is parallel to line M if the measure of angle 5 is 52 degrees and the measure of angle 11 is 76 degrees. Find the measure of angle 3. Okay, first thing right away, I'm going to understand that P and N are completely different transversals, and the angles down here on the bottom have nothing to do with the angles up here on the top. So they tell me a top angle, and I'm trying to find a top angle, so I don't need any of this bottom stuff. Okay, now this is where the colors come in. So 1 is congruent to 6, and 3 is congruent to 8. So I have a angle 5, and I have angle 3. I need to find out angle 3. So I can see that angle 5 has got no mark on it, angle 3 does have a mark, so they should be adding up to 180. So all I have to do is take 180 and take away angle 5, which is 52, and that will give me 128. Okay, next one, 11. It says, are the following pairs of lines parallel, perpendicular, or neither? Okay, what you gotta do is look at their slopes. So A, B, the slope will be 8 minus 3 over 7 plus 2. So 5 over 9. Okay, and then this one would be 12 minus 3 over negative 15 plus 10. So 12 minus 3 is 9, and negative 15 plus 10 is negative 5. So we get negative 9/5. Okay, so I see they are flipped, and one is positive and one is negative, so they are perpendicular. Okay, next one. Again, we gotta solve this for y. So this is going to become plus 8x is going to become 4y equals to 8x plus 3, and then divide everything by 4. So we get y equals to 2x plus 3/4. So this grade, that's what the line is there. So now look at the slope. So 2 versus negative 2. Well, they are not the same. They're not equal because one's positive and one is negative, but then they're also not perpendicular because here they have different sides, but one is not the reciprocal of the other. So they are neither. Okay, and then the last one. We look at our slopes here. We have negative 4/5, and then on this one, your slope is right outside those parentheses, negative 12/15. Well, you got to reduce that. Negative 12 over 15. those can both be divided by 3, so you end up with -4/5, which is the same, so the two lines are actually parallel. All right, almost to the end here. Example 12, it says, what is the slope and y-intercept of the line that is parallel to y equals -1/2 -7 and passes through the point 8, 4? Okay, so first, line is parallel. So what is the slope going to be? -1/2. It's going to be the same. Now we need to find the y-intercept. In order to do that, we actually have to do the point slope form. So we have y minus 4 equals to m, so -1/2 times x minus 8. So y minus 4 equals -1/2 x plus 4 from when you multiply that in. And now we just add 4. So you get y equals -1/2 x plus 8. And that is the equation. And so the y-intercept would be 8. Okay, last one here. It says the following statements describe the rungs and the posts that form the back of a chair. Assume that the rungs and posts all lie in a plane. Based only on the statements, make a conclusion about the rungs, one post, or both posts of the chair back. Explain. Okay, it says the rungs are parallel, so all of these are parallel, and the top one is perpendicular to the left post. So this is that perpendicular transversals theorem. So if you know that you have a bunch of parallel lines and you have a transversal and the transversal is perpendicular to one of the lines, then it is perpendicular to all of your lines. So we can say that the rungs are all perpendicular to the left post. Because we already know that they're parallel, and since the post is perpendicular to one, it's perpendicular to all. Okay, B. The right post is perpendicular to all the rungs. So this is perpendicular here. Okay, so this is that theorem that didn't have a name. It's basically if you have one line and it's perpendicular to a bunch of other lines, then all of these lines that it's perpendicular to are actually parallel. That's that theorem 3-9. So since we know that the right post is perpendicular to all the rungs, we can tell that all the rungs are parallel, because they're all making the same angle with that chair leg or the post. And then the last part here, it says the rungs are parallel, and it says the last rung is perpendicular to the right post, and then the first rung is perpendicular to the left post. So now we have to consider this. They say all of our rungs are parallel. And remember, if we know that the lines are parallel and we have another line that's perpendicular to at least one of them, then it's perpendicular to all of them. And that applies on both sides here, because we know that all of these posts are parallel to each other. And so since the rungs are all parallel here and we have them perpendicular on both sides, we can say that the rungs, all rungs, are perpendicular to both posts. All right, and that's it. So just make sure that you kind of go over those perpendicular and parallel line theorems, what it means to have parallel and perpendicular lines as far as equations go, and then also make sure that you review the relationships between angles for parallel lines cut by transversal, and also their angle names. Other than that, it's pretty straightforward. Just make sure you've studied these 6 things and you should be good to go. See you then.